Hello, in this lesson, we're going to continue to work on the definite integral by substitution method. And this is part B. And of course, we know that we're going to apply the fundamental theorem of calculus part 2. And there are multiple ways to show work. Okay, so please pay attention to if you have questions about how to show work. Okay. So on the first question, we have this function, and we have I think we have done a similar indefinite integral question, but this is a definite integral. The first method, I'm going to show you two different ways. Okay, the solution. Okay, so the one, two, three. Okay. We have, we're going to do substitution, of course. So we're going to introduce u equals to sine x, right? U equals to cosine x. And we also need to work on the table. This table will, we'll switch the variables, the interval of the variable for x to the interval for u. So x and u. Okay, so x could be 0, x could be pi over 2. In either case, when x equals 0, sine 0 equals to 0. And u sine of pi over 2, when x equals pi over 2, and that equals to 1. Okay, so we're going to carry out the substitution. Substitution 1, 2, 3, right? We got to do 3 things in one step. 3 things in one step. First, we're going to, you do your own first order, 1, 2, 3. Okay, so I'm going to substitute this part. That was going to become sine of u, right? Because sine x is u. So sine of sine x is sine u. I will move cosine x. Okay, see cosine x times dx. That's du. So that's a du. Okay, so 1, 2, 3. Part 3. Okay, interval for x from 0 to pi over 2 is changed for interval u from 0 to 1. So 0 to 1. Done. Okay. And the antiderivative of sine u is a negative cosine u. Okay. And evaluate at 0, 1. Okay. That's going to be, in this case, I usually like to leave the negative sign outside. And I would just be doing cosine 1 subtracting cosine 0. What is cosine 1 equal to? Well, cosine 1 is a radian. It's not a, if you punch in calculator, you're going to get a decimal. Okay, but in this case, I recommend you just leave it as is. Okay, you just leave it as is. So we show our work. So in the end, what we got, we will get negative, okay, inside the bracket, cosine 1 minus 1, okay, because cosine 0 equals 1. If you want to go further, you open up the bracket, you're going to get a 1 minus cosine 1. Okay, then we're done. If you think, okay, you need to fetch the calculator to get the answer, let me tell you, it's not necessary. Okay, just leave this, just keep this answer as is, and you are fine. Okay, you are fine. We don't need you to use that calculator. So that's done. So that's one way to show your work. The other way to show work The other way to show work is to work this part as indefinite integral. Okay, another way to show work. Another way to show work, this way of work is instead of having this part, and we remove it and we replace it with just indefinite integral. So basically, we're trying to find antiderivative and use the antiderivative and second order and fundamental theorem of calculus part 2 on the second part. Okay, so once again, so we're going to first try to find, so our first step is to find the antiderivative. To find antiderivative, the substitution part are the same. Okay, the substitution part is the same. So you're going to show that u equals to sine x, u equals cosine x. So then you're going to show the next part of the work to find antiderivative. Okay, so integration, which is indefinite integral, so you're going to get a sine of u du, and its antiderivative is negative cosine u, okay, plus a big constant. And then, okay, you're gonna bring back your u. U is sine x, right? U is sine x. All right. And then, according to fundamental theorem of calculus part 2, let me bring that theorem with us here, right? So according to this theorem, we just need one antiderivative, right? We just need one antiderivative. Okay, let me show you the full screen of this. Okay, we have a family of antiderivative, so you can just choose yours. So you can, if you like, you can say let capital F. Oops. Okay, you can let this F, which is the antiderivative, right? Capital F to be one of it, right? One of it, you can choose C equals to 1, C equals to 0, C equals to 5, C equals to any number you want. C is any constant. So since we only have to choose one antiderivative for the substitution, why don't we just choose the simplest one? And what will make the simplest one? Well, the one when C is 0. Boom. You choose the one that's the simplest. And then you plug in. Okay? And the A in our question is, right? So this is the definite integral we want to work with. So capital F of pi over 2, right? Capital pi over 2 equals to, just put this in. Okay? Plug in this function with x equals to pi over 2. Boom. Right? And the next one, of course, this equals to negative cosine 1. And the next one is a capital F of 0. Capital F of 0. And that's equals to negative cosine 0 equals to negative 1. And the final answer for our question, right, according to fundamental theorem of calculus part 2, will be capital F of pi over 2, subtracting capital F of 0. You see, right? And then what? Just wrap it up. Wrap it up. Okay. So this one equals to negative cosine 1 minus, right? There's a minus negative 1. Minus negative 1. In the end, we still get 1 minus cosine 1. Okay, so that's the end of it. So this is the second way of showing work. You can choose to show capital F explicitly or not, but it's up to you. But at least you should let the reader understand. Your goal is to let reader know that you understand the fundamental theorem of calculus part 2. That's all. That's all. As far as how you show it, that there could be variations. There could be variations as long as your work is clear and understandable. Then it's fine. Okay, and I'm just showing you one version of it. I'm just showing you one version of it as a reference. Okay. All right, second question. Oh, the next question, number 69. Number 69. Let's work on the number 69. Okay. We're gonna put the fundamental theorem of calculus part 2 under for our reference. And of course, I know you guys know it. Let's get started. Okay. We're going to do substitution, of course. The substitution method, I think I'm going to introduce u equals to 1 plus 2x. Okay, then you say, why don't you choose 1 plus 2x squared? Well, I think when we choose substitution, we want it to be simple and useful. And what is the criteria of simple and useful, right? If you choose a squared, then you have to do du, and that's going to make it unnecessarily complex. You can try it. You can try your own way of substitution, and eventually you will find out which way is easier. Okay. All right. So du is going to be equal to 2 times dx. All right. So du and dx, they're different by a constant. And next is a table. We got x, we got u. U, of course, equals to 2 times x. So in that relationship, we will change the interval from x to u. So 0 to 13. And for u, okay, when x equals to 0, so this is going to be 2 times 0, that equals to 1. And for u equals to 13, 2 times 13 is 26. 26 plus 1 is 27. So the interval change it's going to be from 0 to 13 to 1 to 27. And now we're ready to substitute. Okay, we're ready to substitute. And so we're going to have a change of interval. Interval from 0 to 13 now to 1 to 27. 1 to 27. Okay. The function part, we have a u, okay, it's a cubic root of u squared under 1. The x will be replaced by half of the u. So that's going to be du divided by 2. Okay? And then we're going to continue the integration. Continue the integration. We're probably thinking of power rule, right? So on the next step, we're going to simplify. So we take the 1/2 out, right? So we just have a du here and half. Okay? U squared and then take cubic root, and all of this is under in the denominator. So this is going to be u raised to the power of negative 2/3. Okay, then we use the power rule, and we will get the antiderivative of u raised to the power of negative 2/3, and don't forget the half. All right, so leave the half. The antiderivative, okay, which is going to be 1 plus negative 2/3, and u raised to the power of 1 plus negative 2/3, that's going to be 1/3. There. Okay? Evaluated at 1 and 27. Okay, so that's how we're gonna show it. Simplify. Okay, simplify, we have half here, and this part we just basically get a 1/3, right? 1 over 1/3 is 3, so we got a 3 half. And u raised to the power 1/3, so we're gonna put in the bracket u raised to the power 1/3, because now we're evaluating capital F of B, subtracting capital F of A. Okay, so u would be 27 here, 1 over here. Last, almost, okay, equals 2, so 3 half. 27 raised to the power 1/3. 27 is equals to 3 to the power of 3. And we multiply the exponent, and so we're getting 3, right? And the other one is -1. So in the end, right, 3 minus 1 is 2. 2 divided by 2 simplifies, so we get a 3 in the end. That's it. We're done. Okay. Or the other way, okay, or another way to show work, similar to what we did earlier, right? So this whole thing, we're going to replace definite integral by indefinite integral. Okay, we replace it by indefinite integral. And the substitutions are the same. The substitutions are the same. Okay, and our purpose is the same. Our goal is the same. Okay, the goal is to, find the definite integral of this function, of this form, right? So we have the same substitution, right? We have the same substitution. And what do we get here, right? What do we get here is that we don't have to change the interval. We don't have to change the interval. We just want to find one antiderivative. And the other part is also similar. This part is also similar. Okay, so this part is also similar, except, and we don't have the limit. Okay, so 1/2 taken out, and this is u to the power negative 2/3. You can see there's some similarities, so that I was just being lazy and I just, finish up. Okay, and next, the antiderivative, right? Antiderivative, we did it before. So this is this piece. Okay, it's this piece. It's this piece. That's the antiderivative. And we have a half in front of it. So almost the same, except there's not the interval. Okay, we don't need to work the interval. And then what? Of course, this will give us 1/3, and this is going to be 3, right? This is going to be 3, so it's going to be 3/2 plus a constant. And this is not done because we're going to have to bring u back. Okay, we're going to have to bring capital U back. Capital U equals to 1 plus 2x. So 1 plus 2x. Boom. All right. So we're done with the indefinite integral part. The goal to, the purpose of doing that is to find an antiderivative. Okay, so we can apply fundamental theorem of calculus part 2. So we're going to choose the simplest antiderivative, right? So we have this family of antiderivative because C is arbitrary, constant. We choose C equals 0, and we're going to choose just the simplest part of this antiderivative. Okay, and then we're going to apply capital F. We're going to evaluate capital F at 13, right? At 13. And we're going to use the capital F at 0, right? At 0, yes. And what do we get? Okay, so we get these two numbers. Let's see what we get. This part, right? We got 3/2, and this is 27, right? And we know 27 is 3 to the power 3. And so this part is 3, right? That part is 3. So that equals to 3/2 times 3. And that's 9/2. Okay, that's 9/2. The second part equals to, this is 3/2, this is 1, so this just be 3/2. And in the end, our answer, according to fundamental theorem of calculus part 2, is equal to capital F of 13, subtracting capital F of 0. So you're showing your reader you really know your fundamental theorem of calculus part 2, which is 3/2, right? And that will give us 6/2 equals to 3. Finished. Okay, so this is the other way to show work. This is the other way to show work. Of course, there could be variations, but one thing is certain: do not mix indefinite integral with definite integral. If you find an indefinite integral, you just do indefinite integral all the way until you find the antiderivative, and then you apply the fundamental theorem of calculus part 2. But if you want to work with the definite integral from the start, then you just do the 1, 2, 3. Change the interval in addition to the change of function and change of dx to du, so on and so forth. Okay? Just make sure your work is done properly. Okay? All right. So the next one, number 27. Okay, I'm still going to bring this theorem to the next for our application. Boom. Okay. I think this should be enough space. All right. And this one, of course, we're going to introduce, u equals to, I'm going to choose the entirety of a squared minus x squared. And u is going to equal to treat a as a constant, okay? A is treated as a constant. So derivative of u is going to be negative 2x dx, right? So we have x dx, x, you see x times dx. So x times dx is equal to negative half of du, okay? Solving this expression for x times dx by dividing both sides by negative 2. So we got that table, okay? So x u, right? So in that relationship, the interval for x is from 0 to a, and the respective interval for u is going to be what? When x equals 0, and this is just going to be a squared. When x equals to a, and that's going to be 0. Okay, so after the substitution, we're going to do the 1, 2, 3. 1, 2, 3. Okay, 1 is the interval change. Interval changes from 0 to a, now to a squared to 0. Okay, inside root, that's root of u, square root of u. Okay, because that's our u. X times dx, that's equals to negative half du. Okay, but if you write it this way, you're going to lose a point. Okay, you need a parentheses. You need a parentheses. Or you take this part and put it outside. Okay, if you put it outside, you will not need this parentheses. Okay, all right. And next, a couple of things you can do, okay? Because if we look at the new integral, we have a squared to 0. 0 definitively is the lowest boundary of a squared. So we can swap a squared and 0. If we swap this, okay, to 0 to a squared, right? We're going to generate another negative sign. And in addition to negative half, right? So we have a negative half, and we have another negative 1 generated, right? So we have these two generated, and of course, this is going to make what? This is going to make positive half. Okay, negative half times the negative, that's going to be positive half. So it's just for that swap, That swap absorbed the negative sign, so we get a no negative sign anymore. And then antiderivative. Antiderivative root u. Okay, the antiderivative of root u. I'm going to leave the half outside. Don't forget it, right? So we're going to have the antiderivative of 1 over 1 plus half. I've done this so many times, right? So u raised to the power of 3 half plus a constant, no, not plus constant, I'm sorry. This is definite integral Did I miss anything? I think I'm fine. We're gonna evaluate this at 0, lower limit, upper limit. Okay. And next, don't forget to take care of the constant in front. This is going to make 3/2, right? 1/3/2. So that's going to be 1/2 times 2/3, right? And u raised to the power 3/2. We're applying fundamental theorem of calculus part 2. Okay, so this piece subtracting that, and u will be replaced by a squared. And this u will be replaced by 0. Okay, this piece will, after simplification, this will just be 1/3. 1/3. And what does that part equals to? That's a to the power 3. A to the power 3, right? Because this power 2 multiplies 3/2, that's a to the power 3. And that part is 0, right? Minus 0. It's gone. Okay, so in the end, that's it. That's the answer. That's the answer. Okay, so I'm not going to show the second way to show work because I think you got it. Okay, you got it. So the next one, we're going to work on 71. 71. You can see the questions actually getting more and more complex. They're getting a bit more complex. All right. Okay, fundamental theorem of calculus part 2. On this one, the substitution seemed to be obvious. Okay, we're going to introduce u equals to x squared plus a squared. And du equals to 2x dx. Table for change of interval, right? So x, u, right? X from 0 to a. By the way, a is treated as a constant. Okay, so for u equals to x squared plus, for these two, when x equals 0, so this is 0, and that's going to be equals to a squared. And this next one, this is a squared, so that's 2 times a squared. Okay. All right. So now we're ready to change. Here we are told a is positive. A is positive. That's good to know. Okay. So this is 0. A is positive, so a is larger than 0. Okay. So let's continue to do the substitution. Actually, we do it here, right? If you want. 1, 2, 3. Okay, so the interval will change from 0 to a squared, right? So a squared. And the upper limit is 2 times a squared. All right. And inside, right, x times dx is half du. And the root part is the root of u, right? And this part is going to be substituted by du divided by 2. So you're going to bring the 2 in, bring 1/2 outside, so you have a half right there. Okay. And we are pretty familiar with the antiderivative root u. So I'm going to copy this. I'm going to steal this part of the work. Okay. I'm going to steal this part of the work and not forgetting the half. Okay. And evaluate evaluate at a squared and 2a squared. So let's see if that's proper. Yep. Okay. All right, so let's do it this way. Okay, continue. Continue. This is 3/2, right? Under 1, so 2/3. So eventually this is going to be 1/3. Okay. A to the power of 3/2 minus a to the power u to the power 3/2, and substitute u by the upper limit. Substitute u by the lower limit. Okay? You can see it gets a little bit more algebra. We get to do a little bit more algebra, okay? So this would be good practice for all of us, okay? And what do we get? What do we get? 2 times a squared, right? And raised to the power 3/2. So this power will be distributed to half and also to this piece. Okay, be careful, be careful. And the next part, this part is straightforward, right? The exponent just multiply. So that's going to be a equals to a raised to the power 3. Okay, so this just equals a raised to the power 3. How about this one? This one is also a raised to the power of 3. Okay, there's a to the power 3, right? There's 2 times, 2 raised to the power 3/2, a to the power 3. So a to the power 3 can be factored out. Okay, so the a to the power 3 can be factored out. So I'm going to put it here. How about what's inside? Okay, what's inside? I know we might be tempted to fetch a calculator, but let me tell you, just stop here. We're done. Okay, this is good enough. This is good enough before we use any calculator. Okay, no need, no need. You're done. You're finished. Okay, you are finished. Number 72. Number 72. Number 72. Of course, you're gonna try. Of course, you're gonna try to substitute. But then you're gonna realize substitution is not going to. Well, you can pause now and to try to do your substitution. However, when you come back, let me tell you, I realized, from our experience, we have done so many questions after all, and we soon realize substitution is not going to take us anywhere. But notice the interval is symmetrical about the origin, right? From negative pi over 3 to pi over 3. So you may think of this, maybe this function is even or odd. Well, as a matter of fact, this function is odd. Okay, so you can say let f of x. Some of you probably already know the answer, right? Okay. Even odd function, right? Why do we bring this up? We have these nice properties here. For odd functions. So let me copy it and paste that property to our screen, right? So this property is pretty neat. If we happen to have it, just academic questions, okay? we're not solving all the questions in the world. We're just doing some academic questions to learn some mathematics. So first, we're going to demonstrate f is odd. Okay, so f of negative x equals to x replaced by negative x, x replaced by negative x. A sine function is an odd function. Negative x to the power 4 is the same as x to the power 4. And sine of negative x is negative sine x. So this equals to negative of f of x. So this has demonstrated that f is odd, is an odd function. Okay, so this is the proof. This is the proof. Since this is an odd function, therefore, you can say, according to the property here in the box, this integration is equal to 0. Finished. No substitution is needed. Okay. All right. The following questions, we have 1, 2, 3, 4, 5, 6. 6 more questions. These questions all get gradually, I would say gradually harder algebraically. Okay, the substitution part may not be. Okay, some substitution part may be a little bit difficult, but I think we are ready to do it. We are ready to do it. Okay, so let's go. All right, so on this part, we're going to choose u equals to x minus 1. Okay, and u equals to dx. Then you say, how about x? Well, x will be equals to what? X equals to u plus 1. Okay, x equals to u plus 1. All right, just adding 1 on both sides in this relationship. Okay, and then interval change. So we got x, we got a u, right? X changes from 1 to 2. U will change from u when x equals to 1. 1 minus 1 is 0. And when x equals to 2, u will be equals to 1. So the interval change from 1 to 2 to 0 to 1. So now we're ready to do the substitution. Okay, sorry. Equals to 1, 2, 3. We're going to do our 1, 2, 3, right? Interval change from 1 to 2. Now we change it from 0 to 1. Okay, x will be replaced by u plus 1 and the root of u, right? Root of u. We may as well, and the dx is the same as du. So we may write this as u raised to the power of half, because looking ahead, we're going to do power rule. Okay, so 1, 2, 3 changes been made. Antiderivative. Okay, so u to the power half multiply u. So on this part, we will get u raised to the power of 3/2, subtracting or adding u to the power of half. Sorry. Oh, so someone's calling me. All right. Hey. All right. Let's continue. Okay. The rest of the question, I think, it's just you can have a different strategy. You can have a different strategy, and we're pretty familiar with these functions, and we just have to be careful about the algebra, the fractions, and so on and so forth. Okay. So I'm going to show you my versions of it. Okay, you can choose your own version as long as it's correct. I'm not I'm not picky about which way you do it, but you have to make sure every step is correct. All right. So 1/1 plus 3/2, right? So this is going to be u raised to the power of 5/2. 5/2. Okay. And then I'm going to do this. I'm going to do this. Okay. For simplicity. Okay. Interval from 0 to 1. Plus the next one. The next one, which is so similar to the power earlier, so it just half, right? This is just 3. I'm being lazy. Okay. I'm doing my copy and paste. And so this part, I'm going to just put it there. Okay. And so numerically, just be careful. Okay. So here we're going to get 1/5/2. That's 2/5. And u raised to the power of 5/2 minus 5/2, right? So this is a 1 and this is 0 plus, okay? And this should be 2/3. And also the same substitution. Actually, forgive me, I'm playing lazy. Okay, I'm playing lazy. Then we're almost done because the number of bytes, they're not terribly complex. So this is just 2/5. The whole of it is 1. So 2/5 plus 2/3. 2/3. Okay, you find your common denominator. So that's going to be 15, right? So that's a 6 plus 15. That's going to be 6 plus 10, 16. Finished. Finished. Okay. So I don't think this question is particularly harder, but it seemed to be a little bit more work. A little bit more work, which is numerically, you need to be careful. Okay, numerically, we need to be careful. Then the next one, 74. This one, 74. Okay, 74. All right. We are going to do substitution. Okay, I'm going to have u equals to, I'm going to choose u equals to 1 plus 2x. So du would equals to 2 times dx. Okay, du equals to 2 times dx. Since du and dx are different by only a constant, what are we going to do with the x, right? And this is what we can do with x. From this equation, we're going to solve for x, okay? So here we're going to get x equals to half of u minus 1. All right, so then we can do the complete substitution after the table, So x, u, okay? So x is from 0 to 4. U is going to be found, right? U is going to be like that. When x equals 0, U equals to 1. When x equals to 4, U equals to 9. Academic questions, okay? It looks like we're gonna get into some complexity, but some convenience as well. Okay, so let's do the substitution. 1, 2, 3. Interval change. Okay, from 0 to 4 now change to 1 to 9. And this root. Okay, x will be substituted by half of u minus 1. And the denominator is the root of u, right? Root of u. Root of u is really u raised to the power of negative half. Okay, so we're done with this part. Okay, that is u raised to the power negative half. X, we're gonna replace x by that piece. Okay, and how about dx? Dx is half du, so half du. Okay, so we have 1, 2, 3 substitution, but this time the substitution is a little bit more work. But I'm sure you can do it. I'm sure you can do it. Okay. All right. 1/2, 1/2. So that's going to be a quarter. And we bring it outside. So all of these, right? Half is gone. Half is gone outside. So we're going to get, so we're really working on this piece. So it's not that difficult, really. We're gonna get negative quarter. Oh, sorry, not a negative quarter. Positive quarter, okay. U to the power negative half times u, and that's gonna be u raised to the power of positive half. Minus u raised to the power of negative half. Oops, subtracting du. All right, let's finish. Let's finish. It takes a little bit of patience because I know a lot of us don't like to deal with this fractions, but we've done this many times, right? So I'm going to leave 1/4 outside, and I know I'm going to have some stuff inside. U to the power half, I know pretty much that's 2/3 u raised to the power of, whoops, u raised to the power of 3/2. Minus, okay? And what is the antiderivative u to the power negative half? It looks like this is going to be 2 times u raised to the power of half. Okay? Evaluate at 1, lower limit, upper limit 9. You can write it this way. You can write it this way. Okay, go ahead, check your work. Go ahead and check your work on scratch paper. That's it. Next, we're gonna plug in the numbers. Next, we're gonna plug in the numbers. Okay. And if you like, you know what? You can simplify our life just a little bit. Not just a little bit. Take out the 2. Take out the 2 and bring the 2 over here. So you're gonna have half. That doesn't hurt. And then we're going to do the substitution. Okay, then we're going to do the substitution. This part, I'm going to have subtracting u to the power 3 half, right? Substituted by 9, substituted by 1. This part, right? I'm going to do u to the power half. Yeah, this is a 9, and this is a half. This is 1, sorry. And by this time, we don't need this anymore. I'm sure you probably do it faster than I, but I just, because I'm showing you work and I don't want to make mistakes. All right, so I might sound like a little, said too much. This is 1, this is 1, and this is 3, right? How about this? Well, be careful. 9 is 3 squared. 3 squared. And the squared 2 times this exponent is 3 to the power of 9. I'm sorry, 3 to the power 3. Okay? 3 to the power 3 is 27. So this is going to be what? I'm going to save that piece and show you the next part. This is 27 minus 1. That's 26. Okay, this part is 2. All right. Simplify. Yay. Simplify. What do we get? Okay, so please don't let me make mistakes, okay? So take the half and put it inside. Take the half, put it inside, right? You can do whatever. So this is going to be 13. And this is going to be 1. Okay, so 13 over 3 minus 1 is 3 under 3. So that in the end, we get a 10 over 3. Finished. The numerical part seemed to be a little bit, it's a lot of work, right? It's a lot of work. Just be careful. I'm sure you probably get it done sooner than I, okay? All right. Oh gosh. Should we make another video? Should we make another video? How long has it been? Oh, it's almost an hour. Almost an hour. Yeah, let's stop. Okay, let's stop. Thank you for watching. I'm gonna make another one for the remainder questions.